My name is Tuan Haqeem. Okay, this is how our project look alike after we combine the super capacitor and solar application with main circuit controller with encoder. Okay, for my part, okay, this is the solar panel. This is super capacitor, 2.7 volt and 400 farad, and this is the voltage display. This is the main switch, and this is the voltage regulator, controlled by the potentiometer. Okay. Okay, the main function of the supercapacitor and the solar application in this project is to charging the battery when the motor is cut off condition. Firstly, the circuit has a three part, which is charging circuit. This one is charging circuit. Okay, this one is display circuit, and this one is booster circuit. Okay, the charging circuit acts to charging supercapacitor from the input from the solar panel. Okay, the size of the supercapacitor is 2.7 volt and 400 farad. Okay, when we connect it to series connection, it will get 5.4 volt and 200 farad. Okay, for the solar panel, we use the parallel connection. Okay, it will get 6 volt and 1 ampere. Okay, the display circuit. The display circuit acts as the voltage display that's stored in the supercapacitor. Okay, we can enable the voltage display with switch on the toggle switch. Okay, the voltage display stored in the supercapacitor is 4.1 volt. Okay, next, what is the function of the booster circuit? This one is the booster circuit. Okay, as I told before, this is the important in this project. The booster circuit acts to boost the voltage from 3.4 volt until the 34 volt with a condition. Okay, the condition is the supercapacitor must store 3.4 volt above, so that the booster can boost the voltage until the 34 volt. Okay, we switch on the voltage display. Okay, switch on this. Okay, run the okay, we can see the voltage is 24 volt. Okay, I increase the voltage to 24 volt. Okay, if the supercapacitor stored below than 3.4 volt, the booster circuit cannot boost any voltage. If the supercapacitor below than 3.4 volt. Okay, that's why the solar panel used in this project. It can supply voltage and charging the supercapacitor when it continuously. Okay, in this project, the output voltage must be set to 24 volt. We can adjust the variable of the voltage on the booster circuit. Okay, this one, the booster circuit. Okay, then the output voltage connect to the relay 1 that controlled by the main circuit controller under the Mr. Jaafar part. Okay, I pass to Mr. Jaafar to explain the part.
Okay, I'm Jaafar Shah. Firstly, for my part, I will brief the main circuit controller with encoder. Okay. In this case, I will explain how the flow system on this main controller. Okay. This is my part, is main circuit controller. Okay. It is include the relay, which is it is a relay 1, relay 2, relay 3 and relay 4. Okay, and then input section, switch for increase the PWM and decrease PWM, and then display status and value of PWM. Okay, as you can see, the initial PWM is 85 PWM. Okay, I will start the motor, which is I press the increase button. Okay, as you can see, the motor is on and the PWM will be increased. I will show how the motor will be cut off by encoder. Okay, it will cut off and the charging mode will be enabled. Okay, for the same time, the battery receive voltage from the super capacitor, which is the solar panel will transfer the voltage, and then the super capacitor transfer the voltage to the booster. Booster will be charge the battery when the motor is not running. Okay. I will show again how the cut off function. Okay, I will increase again. Okay, it will cut off and the charging mode is on. Okay. At the same time, it will charge the battery to sustain the voltage. Okay, for more information, I will show more detail about this project on this Friday. Okay, thank you.